problem here, I've been given the angle and only one side. Now, since I only have one side, I cannot use Pythagoras to work out this triangle, the size of this triangle. So at some point, I'm going to have to rely on the ratios here from the angle to work out the sides lengths of the radius and the x length, the horizontal length. So since I have to rely on the angle to get the ratio, we're going to have to involve, this implies that we're going to be using decimals in this problem. So that's the first thing I'm going to do. I'm just going to work out the ratios of cos theta, or cos 70, sine 70, and tan 70. So I'm going to go cos 70. I get 0.342. Okay, if I do sine 70, sine of 70 degrees gives me 0.9396, so I'm going to round that to 940. Okay, so what that tells me that for 70-degree triangle, for this shape, the vertical is 94% the length of the radius. Okay, that sounds about right. For 70 degrees, the tan ratio, or the slope of 70 degrees, is going to be 2.747. Okay, so at this point, to be able to figure out the length of these other sides, I'm going to need to rely on these decimal ratios, which I got from the angle. And again, I translated that angle into a decimal ratio in my calculator. So if I want to work out the radius here, I'm going to use the opposite side and the hypotenuse. So that's going to be the sine ratio, okay, or the y in the radius is my sine ratio. So I'm going to set it up this way. So sine 70 equals the ratio 0.941. Now, since it's a ratio, it's always being compared to 1. And that ratio is equal to the y compared to the radius. I can solve for this radius by cross multiplying this and end up with 10 divided by 0.940. So my radius is going to be 10.64. Okay, so I end up with the radius is 10.64. So at this point, since we're dealing with decimal values, I can use Pythagoras to find out this horizontal side. I have lots of options here. I can use the sine ratio, the cosine ratio, because the cosine ratio involves the adjacent side and the radius, which I already know. I can use a tan ratio, since the tan ratio involves the vertical side and the horizontal, or the rise and run. So once at this point I have many options to solve for this unknown length x, I'm going to use the cosine ratio to do that. So here I'm going to set it up as cos theta, or cosine of 70 degrees, is equal to 0.342. And again, it's implied that it's compared to 1. And that's going to be equal to the adjacent side compared to the hypotenuse, or the radius, the x compared to the radius. Okay, so we're trying to convert those values. So we have 0.342 times 10.64. 0.342 times 10.64 gives me about 3.64 when I round that. So x is equal to approximately 3.64. Okay, so using the cosine ratio, I end up with 3.64. Now, it's approximate. There's going to be some error in rounding because now we're using decimal values. And so you're off by a little bit. That's perfectly fine. We could have solved for that x by using Pythagoras as well, or tan. So when we're at that last step, you're going to find that there's many different ways you can do it. Whatever way you find is most efficient is going to be the best way to do it.